Good morning, students. Good morning to all. Today, let us discuss the lesson Nanochemistry. In Nanochemistry, let us discuss the topic on chemical vapor deposition. Chemical vapor deposition is a method to produce carbon nanotubes. Chemical vapor deposition is the process used to produce solid nanomaterials in the form of tubes, wires, and thin films. It involves the conversion of gaseous molecule into solid nanomaterial. Solid materials are first converted to gaseous molecule, and the gaseous molecule are then deposited on the cooler surface of the substrate, forming carbon nanomaterial. So this is the diagrammatic representation for the CVD method. CNT is synthesized using CVD process, carbon vapor deposition, chemical vapor deposition process. Hydrocarbons such as ethylene, acetylene act as a carbon source. Here you can see there is two cylinders, one which contains acetylene or ethylene. So this cylinder is the source for carbon. The another cylinder is containing a nitrogen gas to produce inert atmosphere. And this is a furnace. The furnace is used for heating, which maintains 1000 degrees Celsius. Inside this furnace, the quartz tube is inserted inside the furnace. The quartz tube contains the nanocatalyst. The nanocatalyst supported on quartz or silica material. So this is the diagrammatic representation of the CVD process. High temperature vacuum furnace is used. Inert atmosphere like nitrogen is filled in the separate cylinder. Solid substrate containing catalysts like nickel, cobalt, iron supported on materials like silica or quartz is used. Reaction process. Hydrocarbon gases such as ethylene or acetylene is allowed to pass into the furnace. The decomposition of hydrocarbon take place at 1000 degrees Celsius to get carbon atoms. These carbon atoms condense at the cooler surface of the catalyst, forming CNT. This is a continuous process. High precision and uniformity, control of growth of nanomaterials can be achieved. So there are two types of CVD process, CVD reactor. One is hot walled CVD, another is cold walled CVD. Hot walled CVD reactors are usually tubular in form. Heating is done by controlling the reactor with a resistant element. Whereas cold walled CVD, in cold walled CVD reactors, the substrate are directly heated inductively while the chamber of the walls are cooled by air or water. Applications: electronics and semiconductor, coating for wear resistance, production of carbon nanotubes and nanowires. Advantage of CVD process. Nanomaterials produced by this method are highly pure, it is economical. Nanomaterial produced by this method are defect-free. As it is simple experiment, mass production in industry can be done without major difficulties. Conclusion: CVD is a crucial technique for nanomaterial synthesis, offers control over material properties and structure. Thank you, students. Thank you all.